Hello guys, so I was looking from a long time to do this task for which I had lots of bits and pieces to be connected. So what I wanted to do was, this is my M5 stack Core2 and it is running an LVGL graphic library. As you can see that I have this drop down where I could select some options, I can start and stop. So basically I've made this as a frequency data logger. I am recording vibration data in the SD card provided, and what I'm doing is with the help of mobile device I have made ESP async web server. So I can select the same options from here, and whatever options I choose will be transferred to the M5 Core2 stack, and it will perform the same operations. Now the third thing that I wanted to do, apart from controlling it with the mobile device, was that the data should be uploaded on the Firebase web server as well. Not the web server, but it is a NoSQL type of database. So currently I haven't posted the actual data, but my real challenge was to make three libraries work together. One was this LVGL, which is a very heavy library. Second was the ESP async web server, which is itself heavy because you need Wi-Fi to connect to the web server. And third was the Firebase library. So connecting all three of them was not an easy task, especially when you work with Arduino IDE. So for this reason I went through Platform IO, and Platform IO helps you code very easily, and I selected option of FreeRTOS to, and what I did is these three tasks were actually converted into a task-based system on FreeRTOS, and it allowed me to do this function. So as you can see, for example, let us see first what this does. I can select 50. For example, I want to sample at 100 Hertz. I'll select 100 Hertz and I'll click on start. Okay, it has started, and it is showing me that on an average it is collecting 100 samples per second. And if I click on stop, it will stop. You can sample at 1000 Hertz as well. I will start it, and it will show me that it is showing me that it is collecting approximately 959 samples per second. Let us stop that. Now with the help of mobile, I will be passing the same thing to M5 Core2. For example, let us select click on 50 Hertz, and I'll see if it sets the sampler to 50. Yes, it did. Now let us click on 100 and try to set it. It does. Let us start collecting some samples. I'll click on start. It has started measuring, and it is showing me that it is collecting 50 samples in a second on an average. I'll click on stop. It will stop measuring, and it will go to the main screen again. So this function is performed along with all the three tasks that I wanted to do. The third task that I wanted to test was, if I have a button on my mobile by the name of test. If I click on that test, it should update the data on Firebase. So let us see if that happens. As you can see on the screen, the data changes. I'll click the test button again, and it changes again. So guys, this was something that all the three tasks could be performed together. I hope to release a shorter version of code that I did all together. This is part of my upcoming series, and I know the recordings are not that well, but I'll be recording it again. This is just to show to the community what is possible with M5 Core2. Thank you for watching.